Now we're going to multiply. When we multiply radicals, we're going to start the same way that we did when we added them. We want to simplify each of them separately, just like we did before. So 2, and I got to simplify the square root of 32. 32 we factored into 16 times 2. Then we took out the square root of 16, which is 4, and multiplied that by the 2 in front. So we get 8 square root of 2 when we simplify that first term. Square root of 24. 24 can be factored into 4 times 6, exactly. 4 times 6. The square root of 4 is 2, so we get 2 square root of 6. Now this is the part that's a little different once we get to multiply. What we're going to do is we're going to multiply the front numbers together. We're going to multiply our square roots together. So we're going to do the 8 times the 2, and we're going to do the square root of 2 times the square root of 6. So 8 times 2 is 16. The square root of 2 times the square root of 6 would be the square root of 12. Now at this point, we may or may not be done. What we have to do is look at that square root and decide, can we simplify it further, or do we have to leave it like it is? 12 does have a factor that's a perfect square, so we can keep going to simplify this problem further. So we're going to do that. So if I have 16 square root of 12, 12 can be factored into our perfect square that goes into 12. Or 4 and 3, right? 4 is our perfect square. 4 times 3 is 12. Now if I tried 2 and 6, neither of those are perfect squares, so that's why that pair won't work. But 4 and 3, 4 is a perfect square. The square root of 4 is 2, so 16 times 2 is 32. Square root of 3, and now I have it where I can't go any farther with that 3 because it only has 1 times 3. So, number 11, we got 45. What times what is 45? One of which being our perfect square, of course. Nine times 5, right? 9 is my perfect square. 9 times 5, the square root of 9 is 3, so I get 3 square root of 5. And I have 3 square root of 48. 48 we want to factor the biggest perfect square that goes into 48. There's a bigger one than 4. 16. 16 times 3 is 48, right? So I want to use the 16 over the 4 because that's going to save me some work. So, square root of 16 is 4. 4 times that 3 in front would give me 12 square root of 3. So now I want to multiply them together. I'm going to take the 3 times the 12, and I'm going to take the square root of 5 times the square root of 3. The 3 times the 12 is 36. The square root of 5 times the square root of 3 would be the square root of 15. Now I have to look at that and say, does 15 have any factors that are perfect squares?
Could.
Well, technically 1 is a factor, but 1's not on our list here. 16 is too big, 9 doesn't divide into 15, and 4 doesn't divide into 15. That means I'm stuck. I can't go any farther than that. This is going to be my answer. Unlike with the 12, where I could work it down further. 15, I'm stuck.
So you really don't look at the first numbers then either, right?
Nope,
Look at the
because
second.
that one's already done. You're just looking at the square root to see if you can simplify it. Number 12 then. We have 3 square root of 32. 32, what can we divide into 32? 16, right? 16 times 2 is 32. Square root of 16 is 4, so 4 times the 3 in front gives us 12 square root of 2. Square root of 18. 18 can be factored into 9 times 2. The square root of 9 is 3, so we get 3 square root of 2. So now when we multiply them, what are we going to do?
Square 4.
Exactly. 12 times 3 is 36. Square root of 2 times the square root of 2 is the square root of 4. So we look at our square root. Can we simplify that?
Yeah.
Yep. 4 is a perfect square, right? We don't even have to do any factoring. We just have to do the square root of 4. When we do the square root of 4, what do we get? 2. We're going to multiply that 2 by the number in front, which gives us 72, and there's nothing left in that square root. So we just get a nice whole number on that one. So there's 3 different ways we saw that. One where we ended up with the whole number answer, one where we got the square root of 15 and couldn't simplify any farther, and one where we got the square root of 12 where we had to keep going because it could be simplified more even though we had multiplied it.